This demonstration is going to build on the concepts that I talked about in the last one, talking about the wet and dry climate belts of the Earth. We're going to talk about how those belts shift with the seasons. You're probably aware that the reason the Earth has seasons is that it's tilted on its axis relative to its orbit around the Sun. In the northern hemisphere summer, say in June, we're tilted toward the Sun, the northern hemisphere is tilted toward the Sun, and the Sun heats mostly north of the equator. But if you go 6 months later to, say, December in the northern hemisphere winter, most of the sun's heat lands south of the equator. This means that the heating of the sun changes with the seasons, and that changes the whole pattern of climate and precipitation. Here on this world map, you can see the rising air at the equator is part of what's called the Hadley cell. The air rises, moves toward about 30 degrees north of the equator and south of the equator where it sinks, and it forms a big circulating pattern of air that we call the Hadley cell. Now, where that air converges at the equator in this map view, we call that the ITCZ, and that stands for the Intertropical Convergence Zone. So all along this purple line, the ITCZ, think about that as the place where the air is coming together and rising up toward you out of the map. Now notice this is in January. We're starting in January, and the ITCZ is mostly south of the equator. But as we move into the summertime, we'll get the ITCZ, whoops, let me pull this back to the beginning. We'll get the ITCZ to shift north because the sun's heat is shifting to the north. So you can see that by the time we're in the height of the northern hemisphere summer, the Hadley cells have shifted north, the polar fronts have shifted north, and the ITCZ is mostly north of the equator. And then as we go back into wintertime, the sun's heat pulls the ITCZ back south again. Now let's take a look at what the effect this has on precipitation as I put this back to zero. This shows the wet and dry belts that we talked about in the previous demonstration. The blue represents the wettest conditions, and then you grade into green and then pink, and then the yellow represents the driest conditions. So you can see the wettest conditions in the world occur right where that air is rising along the ITCZ. And then you've got the dry conditions about 30 degrees north and south of there. But watch what happens to this wet belt as we move the ITCZ north with the seasons. The ITCZ takes the rain with it. And so by the time summer comes, all that wet moisture has shifted way far, especially over Indonesia here. And then as we come back into winter, the ITCZ migrates back south and the rain belts migrate with it. Now let's take a look at a couple of specific places to see the climate effects. Look at northern Australia, for example. You see how they're in our wintertime, their summer, it's very wet in northern Australia, and then things dry out as we come into the northern hemisphere summer. But exactly the opposite happens here in Indonesia and India. Look at how dry India is in the winter, and then comes summertime, all the moisture comes in and dumps its rain, and that's a very important time of year for folks in this part of the world because they grow their crops at that time. We can see this effect in California. Most of you are probably live in Southern California. I have students taking the class from all over the world, but usually you're from Southern California. So you know that we usually get our rain in the wintertime, and the reason for that is that these polar fronts where warm air and cold air are colliding kind of migrate south in the winter because all the climate belts have shifted south. But watch how Southern California dries out as we come from winter into summer. Those polar fronts move way up to Alaska, and now we're in Southern California right there. We're right below this sinking air, which is why we have dry climates and clear skies. And then when winter comes again, it brings those polar fronts back down to us and gives us our winter rain. In the next demonstration, we'll talk about cold fronts and warm fronts, the action happening in these areas that we call the polar fronts.